Hello students, welcome back to my channel. Today we will study the topics of ring theory. That is, we will study about that set of endomorphisms of an abelian group is a ring with unity, and that any ring with unity can be embedded into the ring of endomorphisms. Now let's get started.
Now the topic we are doing is embedding of a ring into a ring of endomorphism. Now endomorphisms basically क्या होते हैं? It is a homomorphism from A to A, right? Now let V under addition be an additive group. We denote homomorphism V from V, the set of all homomorphisms from V to V, basically set of all the endomorphisms of V. We will now show that homomorphism of V to V forms the ring with unity under the operations defined by, let's define its operations, f plus g x is equal to fx plus gx for all x belonging to V, and similarly fg x is equal to composition of maps for all x belonging to V and for all f and g belonging to homomorphisms from V to V. Now इसको रिंग फॉर्म करने के लिए पहले क्लोजर देखते हैं. Let f and g belongs to homomorphisms from V to V, then f plus g x plus y is equal to f x plus y plus g x plus y. Since f and g are homomorphisms, so fx plus fy plus gx plus g of y, which in turn implies fx plus g of x plus f of y plus g of y, which is equal to f plus g of x plus f plus g of y, that is f plus g is an endomorphism of V. F plus G belongs to homomorphism of V cross V. Similarly, Fg belongs to homomorphism of V cross V as Fg x plus y is equal to f of g of x plus y, which in turn implies f of g of x plus g of y, since g is a homomorphism, which in turn implies f of g of x, since f is a homomorphism, f of g of y, that is fg x plus fg y, and hence fg belongs to homomorphism of V to V. Associativity चेक करने के लिए क्या करेंगे हम, f plus g plus h over x is equal to f of x plus g plus h of x is equal to f of x plus g of x plus h of x, which in turn implies f plus g of x, if we combine these two, plus h of x, which in turn is equal to f plus g plus h of x. Commutativity can be easily shown. नाउ एडिटिव आइडेंटिटी थोड़ा सा तो आइडिया लग रहा है हमें कि जीरो मैप होगा. सो लेट जीरो एक मैप है फ्रॉम v टू v सच दैट जीरो ऑफ x इज इक्वल टू जीरो. ये o है बेसिकली फॉर ऑल x बिलोंगिंग टू v. देन o is a homomorphism, can be easily shown. Therefore, O belongs to homomorphism V comma V, and F plus O by x is equal to f of x plus O by x, which in turn is equal to f of x plus 0, which is equal to f of x. And similarly, O of f, x is equal to f of x for all x belonging to V, and hence we can show that f plus o is equal to f is equal to o plus f, and therefore o is the zero of homomorphisms from V to V. अब इसका एडिटिव इनवर्स फाइंड आउट करने के लिए टेक एनी फंक्शन f from home of V to V and define a map minus of f such that from V to V minus of f of x is equal to minus f of x. Minus of f is a belongs to homomorphism of V to V. It can be easily shown, and f plus minus of f is equal to O equal to minus f plus f. It can also be easily shown. To prove two maps equal, we prove that they are equal on their domain. Similarly, I will show one part, that is f plus minus of f over x is equal to f of x plus minus f of x, which in turn is equal to f of x minus of f of x, which is equal to 0, which in turn is 0 of x. Therefore, इससे हमें ये पता लग गया that minus f map is additive inverse of home of v to v. Associativity of multiplication, I already told that it can be easily shown. Distributivity can also be easily shown. Hence establishing that homomorphism from V to V is a ring. अब यूनिटी शो करने के लिए हम एक आइडेंटिटी मैप लेंगे such that I of x is equal to x for all x belonging to V, where I is from V to V a map. I can be easily shown that it is a homomorphism from V to V, therefore it belongs to homomorphism of V to V. And to show that it is a unity, we take that f into I of x is equal to fi of x, which in turn is equal to f of x. And similarly, I of f into x is equal to I of f of x. अब आइडेंटिटी मैप है, हर एलिमेंट को उसी पे ले जाता है. So I of f of x is equal to f of x, which in turn implies f of I is equal to f, which in turn is equal to I of f. Therefore, I is the unity of our ring homomorphisms from V to V. Set of all the homomorphisms or set of all the endomorphisms form a ring with unity. Now comes our theorem, which states that any ring R can be embedded into the ring of endomorphisms of some additive abelian group. That's all for today. Thank you.